Hello and welcome back to another episode of Physics Partner. Today we are unraveling a critical concept that underpins classical mechanics, D'Alembert principle. D'Alembert principle, formulated by the French mathematician and physicist Jean-Laurent D'Alembert in the 18th century, offers a unique perspective on dynamics. In essence, it states that the sum of the differences between the forces acting on a system and the inertial forces is zero. In simpler terms, it transforms a dynamic problem into a static one, allowing us to analyze forces at play without direct observation of motion. D'Alembert principle can be explained mathematically in the following way. The significance of D'Alembert principle in physics cannot be overstated. It serves as a bridge between Newton's law of motion and the field of mechanics, facilitating the study of systems in equilibrium. The principle simplifies the computation of forces in complex dynamic systems, making it invaluable in fields such as engineering, robotics, and biomechanics. Let's consider a practical example: a simple pendulum. When the pendulum swings, it experiences gravitational and tension forces. By applying D'Alembert principle, we can express the swing's motion in terms of inertia and forces, enabling us to derive the differential equations governing its behavior, even without measuring the precise angle or velocities directly. Applications of this principle are vast and varied. In aerospace engineering, D'Alembert principle aids in analyzing aircraft dynamics, ensuring stability and control during flight. In robotics, it assists engineers in creating algorithms for robot motion simulations, allowing for efficient energy use and precise movements. In conclusion, D'Alembert principle is not just a theoretical concept, it's a powerful tool that continues to shape our understanding of dynamics across multiple fields. So I think it's enough for today. So thank you very much for listening and watching. I hope you enjoyed the video. I hope this video is useful for you. So take care of yourself and don't hesitate to write an email if you have any question, query, suggestion, and even classes are required. Take care of yourself meanwhile. See you in the next video. Goodbye.